Okay, so if you guys can, do this by Thursday. I'll get those corrected right away so that I can, I basically can tell you guys if you're typing it in correct or not. I'm just going to go through and I'll give you 1 point for each one of the 3 lines typed in correct. So finish by Thursday. And I only say Thursday because we don't have school Friday. All I care is that you try this before you take the test. As for that, we don't have school Friday. And you are absolutely in no way, required to come to this at all. But I will offer, basically just a help session for those who are trying to get ready for the test. So basically just kind of optional class to help you guys out since a day was cut out. Do you guys have a preference for what time you would want me on? Is it easiest for you guys to just keep a schedule, like to do normal class time? Because I could do that. Otherwise, I don't know if you'd prefer it in the afternoon. I mean, it doesn't matter to me. I'm free all day. Okay, so what... Oh, my cat is sitting on the schedule, so I can't see what time we start. What time do we normally start? 10? Let's just say 10 then. So I'll come on at 10 o'clock on Friday. This way, anybody who's watching the video later who's not in class live can at least see that. Otherwise, if you can't make that time and you want some help, just send me a message and I could certainly be on at any time too. I'm kind of required to be on the computer all day somewhat because it's a work day for us to prepare for distance learning, but since I've got everything prepared, I'm free to help you guys out. Okay, the topics for today. I always think they're kind of fun, and I know some people don't like them, but I just think they're kind of fun. So it's the product rule and quotient rule. I'll start with the product rule first. So yesterday I kind of specifically talked about how the properties for derivatives aren't exactly like limits, because I made a point to specifically say do not take the derivative if things are multiplied or divided, because there's a special rule for that. So if you are taking the derivative of 2 items being multiplied, then the answer is going to be f times g prime of x plus g times f prime of x. And before I do some problems with you guys, do you guys, I'll just ask blanket anybody if anybody wants to answer it. Do you know why we have f of x and g of x written there? Like, what is that supposed to represent? Like, what kind of things should I look for being multiplied? So it represents any kind of equation, which could be a bunch of things. It could be like x squared. It could be a whole polynomial. It could be trig. It technically works for constant numbers, but you should not use this product rule for constant numbers. So maybe I will put a little side note there. Whoa, what the heck was that? So works on constants, but don't. I only say that because it would end up being a lot more work to do a product rule with constant numbers. But, I mean, it would technically work. You just don't want to do it. Okay, so let's do an example together. And I'll show you that it works whether you use it or not. So, if we are taking the derivative of 2x plus 1 times x minus 3. Okay? And honestly, you probably had a question like this in Khan Academy already. So I don't know if you remember it or not. Let me show you how we would do it first without the product rule. And then I'll erase it and then show you the way you would want to do it. So technically what you could do is you could FOIL this out. And if we FOILed that out, we would get 2x squared minus 6x plus 1x minus 3. And then you would do the derivative of this polynomial with power rule, which is relatively easy. So 4x to the first minus 5. Now, I'm only showing you this because the example problem that I picked is made up of easier information. Okay? This method only works because we can simplify these two multipliers together and then make it a polynomial. This method would not work if these were more complicated. So let's pretend these get really complicated. Then what you're going to have to do is the product rule, okay? And the first thing you want to do is identify what is f, what is g. Their order doesn't matter. Just one is one. And then what I usually have students do is off on the side, find the 4 things you need to write the product rule answer. Because in the product rule answer, you're going to have f, f prime, g, and g prime. And once these get really complicated, it's hard to do all of it in your head. So just kind of knowing a method so that you can organize your work helps. So if f is 2x plus 1 and g is x minus 3, f prime would be the derivative of 2x plus 1, which is 2. G prime is the derivative of 1x minus 3, which is 1. Okay? So the derivative of product rule is f g prime plus g f prime. And what I'm writing down is generally what you kind of do in your head, but there's nothing wrong with writing it down. F was 2x plus 1. G prime was 1. G is 1x minus 3. F prime was 2. And if we simplify this down, you get the same answer. And 100% I get that one written in green looks more complicated. And so if you had an easy question like this one that was written in pink, there is nothing wrong with doing it on the way I wrote in the white by FOILing that out and taking the derivative. But I'm trying to purposely teach you how to use the product rule. Whenever you have two functions, two variables multiplied together, then the way you take the derivative is with product rule. you guys feel like you follow this well enough to try one on your own, or do you want me to do another example with you? Oh, feels okay already? Okay. I'm just going to combine lots of things we had from the last couple of days because, well, that's what usually ends up happening in the homework. So I don't want you to feel like the homework is more difficult. Yeah, all right. Clearly not person, clearly my cat is the most excited one that I actually bought a computer desk instead of using my kitchen table. She's too old to jump up on the kitchen table. Okay, because I made this one up on the spot, the answer did not work well at all. But I purposely had chosen some different parts of this problem because I wanted to make sure that you would know how to combine all the different things, whether the answer works out or not. And I don't know if you want more time or not. I can certainly give you more time. Gotcha. Well, wait, let me get to that first. I'll start at the beginning. First thing when I'm looking at this problem is I recognize the fact that I've got more than one term. So because there's a minus sign, then that means this is two separate derivatives that I'm going to do. So my first derivative is going to be 3x squared plus 2x times 4 sine x. My second derivative is going to be 8e to the x. The terms means that you do it separately. So that was kind of one of the derivative properties. So I did the derivative of 8e to the x first, because that's just easier. Derivative of e to the x is e to the x. And a multiplier just stays with it. So that's its derivative. The first term, which is a lot larger, I recognize that they're multiplied together. Now, if you want to be technical about this, because you guys are probably good enough to recognize this, 4 sine of x is technically 4 times sine of x. So there's actually 3 things being multiplied. So the product rule works that as long as you group things together as 2 things being multiplied, the product rule will find you the derivative of 2 things being multiplied. So what I did was I grouped the 4 along with sine of x. And so I made 4 times sine of x one term. So I made that all g. I would have gotten the exact same answer if I would have multiplied the 4 out into this parentheses. So you certainly could have done that as well. So when I laid out the 4 things for the product rule, f, f prime, g, g prime, I wrote their answers here. So now, Caden, getting to what you asked, when I'm looking at the answer, I'm recognizing that there are 3 terms. Okay? And when I'm looking at each one of the 3 terms, I see that they all have a common multiplier of 4. And so I factored a 4 out in the front. And that 4 was the only thing that they all had in common being multiplied. Like if I wanted to be anal about it, I could have divided a 2 out as well, but then that would have made this 1.5x, and so I didn't. So I just took out the 4 to make it clean. And honestly, I could care less if you take out the 4. I want you to get in the habit of factoring common terms out, because that's exactly how you're going to see all answers written in multiple choice. And so a big part of my year is preparing you for the AP test, which absolutely looks different for a lot of people than regular class. So that's definitely one of the differences, is the way that AP writes their answers. It's not wrong. You don't have to factor out 4. It just, that's what they would have done. Okay, Caden, did that one kind of answer where the 2 came from? Right, well, because I could do more steps, but it wouldn't get any simpler. Like, I could multiply cosine out to both terms. I could multiply sine out to both terms. But it's not any simpler, so it's just not worth it. Yeah, definitely. So if you want to find the slope of this function at x equals 3, then you would just plug 3 in place of x into this derivative answer, and the answer would be atrocious. Like, it wouldn't work out well. You can make it a decimal or something if you want a single number, but absolutely, as long as you recognize this as the derivative. Excuse me, as long as you recognize this as the derivative, it can be used for whatever. Anybody else have a question? I mean, like, honestly, this is about as complicated as you'll run into. I wanted to try to give you a difficult one. So if you weren't able to get this one yet, I wouldn't feel bad about it, because this is kind of what you're being led up to. But if you feel like you caught on to that tactic right away, that's good. The hardest part that you most likely will run into is once we learn all these different methods of derivatives and things like that, it's hard to know when to use which one. It's not the fact that the product rule is hard to use. It's not the fact that the quotient rule we're about to learn is hard to use. And the power rule is obviously easy to use. It's just that it's hard sometimes to determine when to use them. Okay. Go ahead. Yeah. It would not be wrong. So, if this was a free response question on the AP test, this line would be correct as well. So, AP, the way that the AP tries to explain it to us as the teachers is they will give you full credit as long as the only simplification that's left is just like numerical. So if there's a variable that could be factored out, you should factor out a variable. But if the only thing left to do is numerical, like it's not going to change much, like it doesn't change anything in the problem, it's just a different way of viewing it, then you don't need to do it. I just like to try to make it look like a more formal answer so you'll be familiar with them when you see them. Okay, let me put, I went to Khan Academy and I grabbed a couple screenshots of some of the homework questions they had that are non-standard. And I thought that would kind of be good for us to go over a couple that were non-standard. So this one I would call a hybrid question. It is between normal product rule and a table product rule. And I'll do a table one with you next. So in this one, you're given that g is a function, and you're told g of 4 is 8 and g prime of 4 is negative 3. And then for h, they're actually telling you what the equation for h is. And they want you... Oh, it looks like I completely cut off the actual question. The question would have been, find capital H prime of 4. So this one I thought would be a good one for us to do, because I could easily see it looking confusing, because there's all sorts of mixed information. Now we're told that capital H is purposely a function that is made up of two functions multiplied. And the only reason we would be told that is because h prime of x would be found with the product rule. So h prime would be the first times the derivative of the second plus the second one times the derivative of the first. And I'm purposely trying to say first and second instead of f and g, because I could see it being really confusing for you because g is the first one, which would be normally f. And I don't want you to get thrown off from that. Now, if we're asked to find h prime of 4, then I'm essentially just going to be putting 4 in place of all these x's. And we were told 2 of the answers, and we have to find out 2 of the answers. So g of 4 is 8. G prime of 4 is negative 3. So I need to go through and find out the other 2. Jack. Jack, do you know how I would go about trying to find these other two? Perfect. Yep, absolutely. So h prime of x. And so I don't know if you remember this from the other day from product power rule. You generally can't leave it as a root. We want to write it as a power. So the derivative would be 1/2 x to the negative half. And conveniently, they gave us a 4 so that roots work nice. So h of 4 is one of the answers I need. So that would be square root of 4. H prime of 4 would be putting 4 into the derivative. So a negative power means I move it to the bottom. A half means square root. So 1/2 times 1/2 is 1/4. And I don't know if I went through that too quickly or not for you. Absolutely, if you guys have a question on something I put up there. It doesn't even matter if you're just confused why I wrote something, you know. Like, it definitely benefits you to ask right away. And I'm more than happy anytime you guys just ask. Okay? Why don't I put one up for you guys just to do on your own? It's going to be a table. It's not like this one. This one is like a mixture of a table and a regular question. I think it's this one. It is this one. Why don't you guys just take a minute and see if you can figure this one out. Wait, I wrote something wrong. I wrote prime twice. So these table ones, they actually look kind of confusing at first, for sure. Because they don't give any guidance, they don't give any equations, and I know that usually scares some people off right away. But they're actually traditionally much quicker and easier because you don't have to do any of the work. So the majority of this is just knowing the product rule. And g of 0 would be negative 3, h prime of 0 is 3, h of 0 is negative 1, g prime of 0 is 5. So negative 9 minus 5, negative 14. And they're honestly, the product rule itself doesn't get any tougher. So I'm not sure what you guys, if you guys are realizing it or not. So if I go back to the original one I did in pink, the only thing that gets tougher is what equations go in place of f and g. Okay? So, like, maybe there's a bracket. I know I'm pointing to the screen, like you can tell where I'm pointing. Can you see the mouse pointer move on your screen? Okay. So let's say we look at f. Maybe f is like its own bracket of a separate product rule. So it's kind of like you have a problem within a problem. Get out of here. It's kind of like you have a problem within a problem. The reason I like to have everybody set up the work off on the side like this is so that you can organize your work. So no matter how complicated F is or G is, then you can kind of organize your work and try to, separate things in your mind. Because it's going to be really easy to get overwhelmed with information if you try to do it in your head. Like some of you guys are generally just, you're smart enough that you did a lot of in your head in pre-calc or else too. But you most definitely have to get used to writing things down now because the work just gets too complicated. It ends up being too complex. Okay, now I'll go to the harder of the two, which is only harder because the formula is harder. So this is called quotient rule. And now that we're going to be switching to distance learning, I have a feeling that a good portion of everybody is not going to be using their Chromebooks much. I'll pretend you're using your Chromebooks, whatever. I don't like to use GoGuardian. The only reason I may bring this up is when I was talking to you guys about making note cards for this unit, one thing that I had definitely seen that somebody did on their computer in past years, whatever, is they use that little Post-it note app. And they put a Post-it note on their desktop, and they just kind of continually keep writing in the formulas that we learn, and then just leave it there. So it's kind of like right next to your homework. And that works really well. I mean, then you're not going to lose the note card. You don't have to look it up. So if you guys have that app, it usually works pretty well. So if we take the derivative of two functions being divided, then the formula, and this is kind of the annoying part because it is reversed from product rule, is gf prime minus fg prime all over g squared. G of x squared. So the problems are definitely not going to be more complicated. What becomes more complicated is just the simplification of the answer. I don't know if I want to try to give you a hard one yet, or if I should give you an easy one to start with, just to show you how it works. I guess we should start with an easy one. So if we take the derivative of x squared plus 4 over x squared minus 1, okay, first thing that I do is I identify that I have a derivative of two different functions being divided. So it's two different equations being divided. So that means quotient rule. So underneath is, or, off to the side, I don't care. It doesn't matter how you set it up. I usually like to set up my different answers so that I can just write them in rather than try to do it in my head. So F is, this one it does matter the order. F is always the top one. For the product rule, it didn't matter because you could reverse it. But F is always top. So G of X, F prime, F of X, G prime, G squared. Okay, just by the nature of the way these are set up, they often simplify. First thing I will tell you, don't ever square the bottom. So that is definitely something I see traditionally over the years. Just because I know some of you are very anal about the way you like your work written, and so it kind of bothers some people, like if it's not. Well, it's like math OCD, right? Like if you see something to do, you just like want to do it. Don't do anything to the denominator, because what you're going to do is you're going to wait to see something may cancel from the top. So you don't want to do anything to the bottom. Next tip. You cannot cancel the x squareds minus 1s. Number one error in quotient rule I see. Canceling only works if it's multiplied across the whole top. So the first thing I see a lot of people try to do is cancel an x squared minus 1. It doesn't work that way. What you're going to have to do is look at the top of the fraction. So I have two choices. I could either multiply out the two x's to everything on top and then just join things together. Otherwise, let me change colors there. I see that there's a 2x being multiplied on both of these, which honestly was just pure chance for this problem. But that means I can factor 2x out. If I factor 2x out, I'm left with x squared minus 1 minus x squared minus 4. Lila? How come I have two minus signs right there? How come the one in front of the 4 isn't a plus like it was up above? I distributed out that minus sign. Okay? Good. Good. It's easy to miss that when you're doing the factoring. It's easy to just drop the parentheses. The algebra errors are pretty much all the errors in calc. It's not usually going to be the calc errors like the quotient rule. It's like doing the work is where everybody makes errors. So I'm simplifying down. It looks like x squareds cancel out. And I'm left with times negative 5 over x squared minus 1 squared. So to be honest, I can actually combine those. And then that would be my simplified derivative. Now, before I give you guys one to try, and then we'll be done after that. But before I give you guys one to try, do you want me to? Yeah. Two times 5. Oh, because I totally forgot to write it. Gotcha. I totally did not even understand your question because I didn't realize I didn't write it. Sorry about that. The horrible part about teaching a difficult class like Calc is while I'm trying to concentrate on talking and teaching everything, it's like writing what I'm talking about doesn't always happen. Okay, so this one feel okay to you guys? Okay. The factoring is often where I get most of the questions. So I'm going to choose a question for you guys to try that I know should factor, because I want you to practice the factoring part. So, wait, let me reverse those. Let me put the square root of x on the bottom. Sorry if you're using a pen. So this one should simplify. Yeah. Oh, dang. Very good catch. I gotta start all over. G prime. Yeah. No. Oh, G goes first, not G prime. You know what? I'm trying to remember. I do all the formulas off the top of my head. G, F prime. Minus F. G prime. And then instead of writing square root of x, that's not the eraser. Instead of writing square root of x, I'm going to write that as x to the half. Okay, so I'm just going to anticipate almost all the questions I'm going to get come from right what I factored out and what's left. And I don't know if that's correct or not, but the reason I chose this problem is because the square root of x's are traditionally where most people run into factoring issues. And I'll kind of wait for most of you to get to there before I explain it, so that you can kind of watch. Okay, so the portion of this, I have two different x's on the top. I have an x to the 1/2, and then I have an x to the negative half being multiplied. So they're common factors. But you have to determine what power goes on the x to factor it out. So I'll go back to what I wrote in red here. This is what you traditionally were used to. Something like this, x to the 8th plus x to the 5th. And I think you guys just naturally know by now that you would factor out x to the 5th. And without you even realizing, like, you instinctively knew to take out the smaller number. And the reason what you're going to do is when you factor out the smaller power is that you automatically subtract the powers. So if I factored out 5, I take away 5. And dividing out x to the 5th from x to the 5th leaves it as a 1. But the power that is left, the power that's remaining, you get from subtracting them. Okay? So if I'm up here, I have x to the positive 1/2 and x to the negative 1/2. Negative 1/2 is a smaller power. So that's why I choose to take out negative 1/2 from both. Now, if I factor x to the negative half out of x to the positive half, the power that's remaining would be positive 1/2 minus what I factored out was negative 1/2. And so this becomes x to the first. And then over here, if I factor out x to the negative half, from it would just be a 1. And this just, it doesn't feel natural for most students to do this, because this is probably the first time that you're used to factoring out strange powers. But you generally are going to factor out the lowest power of the two. And then when you do that, you subtract it from the power that was there. And then all I did was multiply out the half and combine the top. And I moved x to the negative, it didn't change colors. I moved x to the negative half to the bottom. So that's where the x to the 3/2 came from. The square root of x's on product rule and quotient rule are generally where a lot of the algebra errors come in, because you're just not used to dealing with those kind of weird powers. I would be expecting the third step on the test, because the factoring out a variable is traditionally considered what needs to be done. If it was just a number that they had in common, then that's not a big deal. Oh, go ahead, Mackenzie. Yeah, when you yep. So I had 1x minus 1/2 x minus 2 times a half is 1. So 1x minus 1/2 x. That's, yeah. They combine together. It just doesn't, yeah, it doesn't feel like. There's tons of fractions whenever you deal with the roots for derivatives. Okay, what time is it? 11:03. Go ahead. It's just square root of x. So g of x is just the denominator. Oh, yeah, no, you're correct. That I didn't even think to bring that up. So you're right. Being on the denominator is kind of like 1 over, except that the way the quotient rule is written, the denominator itself is just g of x. Okay, and this is a pretty difficult one. Again, because of our shortened time and crammed everything, I'm trying to give you difficult stuff in the notes, just so you're kind of used to it. So don't feel bad if you're not there yet. You know? I do have a quotient rule table I could put up, and I didn't know if you wanted to do that or if your brain was shot. Doesn't really matter to me. I think we only have 10 minutes left anyway. I'll quit here then. I can see your eyes look drained. Okay, so I'll stop the recording.